Okay, so if there's any issues of you wanting to present, I want to make sure that it's a good environment for you to do so. And so that's what the goal of the Rust Gamedev Meetup is. And first and foremost, I do want to say that we are going to be following the Rust Code of Conduct. I'm not sure if Rust Gamedev has a particular code of conduct, but the Rust Code of Conduct is pretty good. And so the reason I want to start with this right off the bat is because I want to make sure that this is a place where people can come and work together and see what people are working on, and not feel bad when they leave because something went wrong. And so if at any point something isn't going right for you, please feel free to message me or any of the other admins on the Game Development in Rust Discord server, because I want to make sure that this is a very sustainable thing that can go on. And then the Code of Conduct, I'll just toss the link for that in the Discord for anybody who wants to check that out. All right. Yeah, so to start off, welcome. This first iteration of the meetup is going to be very, very open-ended. I think that there's going to be a lot of things that go very wrong and aren't ideal and don't work out properly, but we're going to try and iterate on it. And so the Rust Gamedev Meetup is going to happen on the second Saturday of each month at this time, which is 11 a.m. for me and 4 p.m. for a lot of people in the GMT time zone. We might move it around depending on if something else works better, but I think this one should work pretty okay. And so the schedule for this, I want to start by doing introductions at the beginning of each meeting and kind of just go over anything, maybe get people up to speed if they haven't been out before. But I do want to quickly get into the show and tell of what people have been working on. And so for the show and tell, how it's going to work is that pretty much you can either screen share and talk about what you've been working on. You can send something to me and then just talk in voice, and it should be relayed to everywhere. Or you can just send me pictures of what you've been working on and I will show them off. I want it to be super open-ended, and so while we have the Rust Gamedev newsletter that kind of highlights a lot of different things I've been working on in Gamedev, this will be kind of a video version of it, I hope. And speaking of, if you haven't checked out the Rust Gamedev newsletter, it is a very cool newsletter that happens every month that goes over a lot of different projects that are happening in the Rust game development ecosystem, and so I'll post that in the chat as well for anybody who wants to check that out. And there's a lot of really cool people here who are working on some really awesome things in Rust. And also, I should specify, we do have 67 viewers on Twitch, some of whom may not have come from the Discord and may not know which Rust we are talking about. I do want to specify we are talking about the programming language Rust, which is very, very often confused with the video game Rust, which is also very popular right now. And so if you are here for the video game Rust, I'm sorry, but there's much larger streamers on Twitch that are showing off that video game right now. And so for this meetup, it is just Rust language and specifically game development in Rust. All right, so I think I've gotten everything for the introduction all taken care of. So we'll move into the show and tell. Yeah, I'm sorry for people who are wanting to come and check out the Discord, but it is full, and that is just because Discord's streaming limit is 50 people. But hopefully the Twitch accommodates well enough. Yeah, I see some people talking about how the turnout is pretty good. This is definitely more than I expected, so it's very cool. Oh yeah, so actually I had this for introduction as well. So hi, I didn't really introduce myself yet. So my name is Forrest. I live in Canada. I'm a student in Canada, and I within Rust I mainly work on the Vulkan project, and I do a lot of what we call the meta team work, and so kind of everything in between the lines when it comes to writing the blog, doing interviews, reaching out for different social stuff, and then also a lot of DevOps kind of stuff, working on improving the compiler for what we need, improving continuous integration and stuff like that. And then I'm also very recently have become the co-host of the Rust Gamedev podcast, which I'll talk a little bit at the end in the announcement section. Oh, and speaking of, if anybody has announcements of interesting things that are happening in the Rust Gamedev community, also feel free to DM me, and I will put them at the end of the meetup. So I think I already Oh, nuts. Okay, I made the slideshow like half an hour before we started, and so that's why I have the template text here. So if you're wondering about Mercury, you can find out a little bit about it there. Yeah, so this is sort of like the general plan of how I imagined it is to be a place for people to show off the stuff that they're working on, to hang out with other people in like the Rust game development community in a more sort of like meet up at one time kind of thing, rather than the asynchronous, whether you're replying to issues on GitHub or just messaging on a Discord or anything like that. Yeah, so that's kind of the plan. So we'll start. We'll try to do some of the show and tells. There's a couple people who have already messaged me, and we will go through them, and they can talk about the stuff that they're working on. So we're going to start off. So we do have Fish in here. Fish is going to be talking a little bit about simple physics. I'm just going to give Fish the role, and we're going to see if everything works for that. Fish, are you able to... Okay, I think I can hear you.
Hey, can everyone hear me?
Yes, we should be good.
All right. So to be completely honest, I thought this was next week.
No worries, no worries.
But I have presented this a few times, so I think it will be okay.
Perfect. Do you want to screen share?
Yeah.
All right.
All right. So this is one branch of simple physics, which is called simple mechanics. Simple physics as a whole is a set of multiple physics simulators, including currently simple mechanics and simple gravity. One of which is for rigid body mechanics, this one, and the other one is for universal gravitation. And rigid body mechanics and universal gravitation are essentially the first 2 units of high school physics. And these simulators are meant to help students teach themselves and to help teachers conduct labs without expensive lab equipment and such. So to facilitate learning, there's a few helpful features other than just the physics engine, which is nphysics actually. You have inspection of the various like values of an object, and more importantly, you can graph them. So if I want to graph the speed of this, I can put it here. And you see if I throw it, it's like a nice parabolic arc. So using these sort of features, you can make labs, and the labs are written in Lua. Basically, you can add objects using Lua. You can manipulate them later. You might have noticed I made Flappy Bird using Lua, which is kind of interesting. But this lab is a bit more practical, and it's just a simple collision lab. So this is modeled after a lab that we did in high school physics. Essentially, each row is a different type of collision. The top 2 are elastic collisions, and the bottom 2 are inelastic collisions. And then they're equal mass and different mass, respectively. So you see that there's different outcomes for each collision here. If I graph the x velocity of them, I accidentally grabbed the object there again. Then you can see the velocity is just swapped. And of course, that's something that we learn in physics. If 2 equal mass bodies collide in a perfectly elastic collision, their velocities will just swap. So another lab that I created, which is a bit more fun, is the K-NIT lab, which is also modeled after a lab that we did in high school physics. Essentially in high school physics, we had a ramp and a marble, and we were supposed to predict where the marble would land on the floor if we rolled it off the ramp. And it was pretty stressful because our teacher told us, if it takes you 1 try, you get an A. If it takes you 2 tries, you get a B, etc. As it turned out, the teacher double-checked our work, and pretty much everyone got an A, so that was nice. So here, given the distance between this point and here, which you can really only find from using the Lua preset right now. You can calculate the speed that you need to propel this at to land it here, or more accurately, the x velocity, and it will kind of recalculate the y velocity. So in this case, I know it's -10. Actually, I might be wrong, but we'll see. Yeah, so that was way off. This lab is actually also double-ended. So that was a projectile motion lab, basically, if I just calculate the speed. But it can also be like a rotational energy type lab if I up the friction so that it actually rolls. Sorry. Yeah, so if it actually rolls, then you get a different outcome because you have to recalculate the energy. Oh, I got it. All right, so one of the cooler features actually, oh, I accidentally closed the stream. Wait, did I? All right, never mind. Yeah, one of the cooler features is that using the Lua scripting, students can write their own physics. So this is not something that I had added previously, but actually I was talking to my physics professor in university, and he suggested it. So using the Lua scripting, students can write their own collision functions, for example. So let me pull up the code for this. All right, I'm going to change my screen share. All right, I'm not sure how legible that is, but you can see that this is a collide function, and it's some pretty simple vector math to just calculate an elastic collision between equal mass objects. And my Lua is a little bit amateurish probably because I really just learned it to write this. But you can see that adding an update function to a shape as you add it, you can essentially do anything with the shapes. So while the collide function is one example that I came up with, realistically you could write almost anything. And I'm interested to see what my physics professor or other physics teachers could come up with. So let me demonstrate that it actually works by changing my screen share back. All right, yeah, so collisions are completely disabled in end physics for these two objects, but as you'll see, the Lua still works pretty well. And there are some bugs, yeah, there, but for the most part it works, and I'm pretty happy with that. And here's Flappy Bird, which is completely written in Lua, and it doesn't have user input, but I wrote an AI for it, and I think that's cool. All right, so that's kind of the end of my presentation on this.
Yeah, that's super cool. I think for myself, one of the big things when I was doing like high school physics and stuff like that is that it's cool to see stuff moving around, or to like look at the fact that you can take a projectile and have it fire and then do the things that you predict. But in being able to like look at the plots and how like acceleration maps to velocity, maps to position kind of thing, that's something that's incredibly valuable for people to experiment with. And this reminds me a lot of like 3 Blue 1 Brown. Their videos are incredibly great at teaching because of the way that they display so much of the information. And like this graph is super cool. I like this a lot. Yeah, I think this is a pretty cool project. So is this one that you're working on sort of like open source, or working on just yourself?
This is completely open source. I'm actively looking for contributors because I've been working on this since junior year of high school, pretty much. And I'm kind of tired of it.
Oh yeah.
But also, more importantly, is I really want more labs. Because I'm not very good at writing them. I would really like people with more of like a physics background to help with that.
Yeah, for sure, for sure. I think I'm just trying to find the GitHub link right now. I think I have it. I'll post it in chat for people. Okay, yeah, simple gravity. Is that one of? I guess that's one of them.
Yeah, that's one of them. And the main repo for the project as a whole, I guess, is simple physics. It's pinned on my GitHub profile.
Okay, perfect. Yeah, simple physics. All right, so I'll post that in chat for anybody who wants to check it out. Because everybody's muted in chat, I see a lot of claps, so I will give you a clap of my own.
All right.
Yeah, so that's super cool. I definitely like seeing this. All right, thank you very much, Fish. So,
yeah, thank you.
Yeah, you bet, you bet. So moving on, next up we have Tarash, I believe is how you pronounce your name, and Tarash is going to be showing us about Dotrix. And for this one, let me see. So there's a few YouTube videos here, and I will give you speaker privileges. There we go.
Yeah, can you hear me?
Yes. All right, so I think I'm gonna pull up the videos. I think they're in order.
Yeah, super.
All right. All right, perfect. So we'll get started on the first one whenever you like.
Yeah, super. Hello everyone, my name is Elias, and I'm one of Dotrix developers. We decided to make a game in our company and decided to do it in Rust because we really like the language. And here is the very first demo of our engine we've been working on, and this is actually what I was expecting to get from other engines when I just started my game dev experience with Rust, but there was nothing like this yet, and this is what I wanted to have. A terrain, some character, animated character with skeletal animation, some skybox, light, of course, and during about 3 months of development, we get our engine to this state. And right now, we are working on further features. And one of them is editor for the world. You can switch to the next video, I think. Yeah. Here's the first results of our editor application so far. It's Martian cubes based. In this case, we are using EGUI library. Very nice library, by the way. And we can generate some terrain using fractal noise, the different stuff. This state of application is more like proof of concept of generating the terrain using the noise. Now we are getting to the further steps of this. We're working with brushes. There is also a video for this. And what I wanted to have in the end is a complete editor for the world with texturing, with sculpturing of the terrain. So you will have possibility to really pre-generate your world, adjust it in the way you want, and as export for your game, you can have 3D map of density values that you can use to generate the mesh, and as well you can use them for physics, for collision detection and so on. Yeah. Yeah, this video shows already first tests with 3D brush to generate a sphere and to cut a piece of it. This is very close to the current state of editor application. And it's all open source. It's available on GitHub within Dotrix repository. You can check it. I probably should send a link.
Yeah, if you send a link over to me, I'll toss it. Actually, it might be right here. Is this it? 3D engine written in Rust. Oh, yeah. All right, perfect. Yeah, so I'll toss this in chat for anybody who wants to check it out.
Yep.
Yeah, so this is pretty cool. What has your experience been with like using UI stuff within Rust?
This is quite nice library. I wanted to have something. There is another guy, another developer, which is working for Dotrix solution for UI, but I recently just received a tweet about new version of EGUI, and I decided just to give a try, and I integrated it in a couple days, and it works as expected. Of course, there are some minor issues, but they are not bothering me at this moment. So my first experience is very nice.
Awesome. Yeah, this is pretty cool to see. I do like yeah, you can just kind of see demos of everything working together, physics working nicely and everything.
And maybe one more important thing to mention is that I really try to make it work on not expensive, not powerful laptops. Trying to optimize things. So this all works on integrated Intel GPU.
Okay, and sort of like with working in Rust and working with parallelism, like sort of like in such an easy way compared to other languages, have you kind of experimented with what you can do there, or is it mostly just optimizing for GPU?
Well, this is the question of optimization is a complex question.
That is true.
I use parallelism, of course, but it's not only the case. I started to use parallelism only for Martian cubes, to be honest. Rest of the Dotrix part is single-threaded, and only assets are being loaded in background. For Martian cubes, I use Rain library and parallel iterators, which suits perfectly, and it really gives a significant boost to generation.
Yeah. Oh yeah, sorry, I didn't have anything else in particular. I think this is definitely pretty cool.
I tried to generate these terrain tiles of size 256 by 256, and with single thread it takes like, I don't know, maybe 15 seconds, while with Rayon it's almost instant.
Interesting. Yeah, this is pretty cool. I think for myself, I definitely like looking at a lot of the progress here, but I think under the hood, I don't understand everything that is going on here. So I hope that a lot of other people are getting some pretty cool stuff out of it. It's awesome to see this kind of stuff being shown off, and I'd like to see it in like future meetups, kind of how it's continuing and how the engine's going. That'd be kind of cool. All right. So thank you very much. Is it Tarash? Your name?
Tarash, yeah.
Tarash, perfect.
My name is Elias.
Elias, perfect. All right, you got getting a lot more applause in chat. Very good, very good.
Thank you.
A lot of people are mentioning that I need to get some like a soundboard of to use. Also, I should mention a lot of people have been messaging me about how to use Twitch properly and stuff like that. And so if there's anything that I'm doing that seems off or not working, or even within Discord something's not working, feel free to just direct message me, because I'll definitely see that. And I'm very certain that if you think I'm doing something wrong, I am doing something wrong. Yeah, and I think the other thing that's a little bit harder is stream on Discord. So I think some people had some black screen for a while, and then also I had like an infinite screen going in on the physics one. All right, so we'll move on. Next up, we're going to have Gidshen talk about a Vulkan Rust-based game that they are working on. So I'll just give them speaker permissions here. One second. There we go. Let's see.
Leave?
Yes, I think. Oh, pardon me?
So I think I got it. Do you see my screen?
Yes, let me just see if I can do this.
I'm not crazy familiar with Discord either. Okay, I think you can see my screen now, right?
Yes, we should be good.
Okay, great. So yeah, I'm here to pour some gasoline into this discussion here because I'm using Rust, but I'm not using Cargo. I'm using my own build tool. And I guess I would present a little bit of my motivation behind it, where it came from, and how it works so far, and what I'm thinking about doing that. A little bit about me. I've been working as a game developer professionally for the last 5 years. I was actually introduced to Rust by Still Alive Games. This is this company where we actually considered using Rust for a bus simulator, if someone knows the game Bus Simulator. And we were thinking about if we can do it for some traffic simulation and stuff for concurrency, but ultimately decided against it due to getting to run on PlayStation and stuff, which wouldn't have been a lot of fun. Maybe possible, also maybe not covered by Sony that you're allowed to actually do that, but we were thinking about it for a while. So I have worked as a graphics and gameplay programmer for a little bit, and I'm looking around at all kinds of languages. I love different programming languages, and so I'm experimenting a lot with how far I can take certain things, and also currently a lot how much I can take away. So I'm using Rust C directly with my own build tool. The idea behind that is that a game project consists of many different kinds of assets, lots of things where there's different kinds of outputs, right? There's not just code. And with with tools like Cargo, for example, they mostly focus on one programming language, Rust, and not a lot on data assets, for example. And they try to make data assets sort of a second class citizen. And I would like to have all different kinds of assets or some kind of first class citizen.
Sorry, just a quick thing. If you click on the main screen, can you just hit Control Plus a couple times just to make it a little bit bigger?
Yes. I wasn't gonna. Perfect.
There we go.
I guess as an example for that is a game that I've recently made. It was for a game jam. So this is an entire engine, inclusive of the build tool that I've made in about a month. And this is C++ only. I've now extended it to Rust because I want to convert as much of it to Rust. And here, GLTF files, images, GLSL code, and C++ code all have sort of the same rank in what kind of asset they produce. And it supports progressive compilation of GLSL code, C++ code, GLTF code, and other kind of data assets. And it puts it all into the folder in a very specific place. Something I don't like about Cargo, for example, is that there's very little option to actually copy things like DLLs or other data assets next to your assembly. And the way I want to have it is to have actually something that I can just zip and send out in the final target folder without any kind of intermediate assemblies or object files or whatever. And so this is a game I've made with Vulkan and this build tool. If I recompile it, which shouldn't take long, I think it's already done. Shit, that's the wrong one. December. If I rebuild it, okay, everything is up to date. The game jam game. Come on. It's just some stupid game jam game with a little bit of physics and built with my own build tool. And I've wanted to, my project is to convert most of that game jam game to Rust. And so I'm using my own build tool that I've extended now where right now there's only like a C and Rust. And I have my application here in Rust defined as like the application that I'm making, plus all kinds of services. Additionally, for this project, I'm not using a Rust standard library. I'm not linking against the CRT at all. And so I'm implementing my own heap, for example, my heap allocation using the Windows APIs, for example. And so I have a very unique build pipeline that puts out very small binaries in the final folder. And all of the intermediates are here, defined by just some XML project file syntax where I have different C++ projects. I can have filters for which configuration, which platform. For example, for Windows, I define other compiler arcs. I can define dependent subprojects, so everything is compiled concurrently, but it waits for subprojects to complete. So if there's any dependencies, it waits for those to complete before it compiles the rest. So it's progressive, it compiles everything progressive and or in parallel as well, including the C part, which looks up which headers are included in each file and builds a dependency tree, which headers are updated. And this works for GLSL, C, and Rust, so they're all under one umbrella of working very similar. So this would be a Rust project, which works very analogous to a C++ project, with very, very limited the build tool does as little as it has to. The idea of it is that it is as thin a wrapper around Clang or Rust C as possible. So I specify all arguments in the project, in the config file. So there's no abstraction of that. So I'm trying to have or experiment with having as thin of an abstraction of it as possible. That's ultimately my goal. For where the things end up or to look what it compiles, it replaces all kinds of path variables or other variables like the temporary directory, which maps to this thing up here, the project name and stuff. And so it's as thin a wrapper around it, around Clang, Rust C, and everything as possible. And it seems to work quite well. So if I would delete just something out of the output directory, it only recompiles those things. It tells me which projects it compiled, and it then at the end gives me the times for everything because I'm trying to have as quick compile times as possible. Yes, that is, I think, about it. This program doesn't really do anything yet. So I don't think that's all that interesting what it does right now, since that's just a proof of concept of the entire thing, where I'm experimenting with just that it works, basically. And then I'm going to write all of my abstractions above that. Where I'm also going to try out different ways of abstracting the collections and stuff, because it's all a big experiment, basically. Yes, I think that's about it. I hope it was all right for presentation. I didn't prepare anything. I saw the ping while I was working on this in the Discord, and so I just asked if I should present this.
Yeah, that's super cool. I think I've played around with Rust C only because one time I thought that I couldn't do something in Cargo, but then I found out that I could do it in Cargo, and then I quickly hopped back to Cargo. But I've been quite interested because I remember coming from like learning C and C++ in university and having to do a whole bunch of compilations or like a massive like compilation line, and so this is pretty interesting. I never really thought about approaching it like this, so this is pretty cool.
And something which is something that I think very strongly about is that a lot of things are way easier behind the curtain than a lot of people think they are. And it's always a very good idea to look behind the curtain, even if that's not the way you're going with. But seeing how easy certain problems are, I think is very interesting. For example, this entire build tool, I've written it in C#. It isn't a lot more than 300 lines of code, maybe, the entire build tool. So this is like the compilation for all of the different GLSL projects, Rust projects. And I can zoom a bit. I mean, it's not really interesting what's happening here, but this is the XML that gets serialized. That's all it is, and then it gets compiled here. And there's like certain replacement stuff and collecting and filtering the different platforms and stuff. But it's not a lot of code for progressive, very solid C++ compilation. I've worked on this game jam game right here with 2 other developers. We didn't have any stale builds. We didn't have any corrupt objects files or assemblies or anything. So it worked really, really well. And the setup was incredibly easy as well. Easiest project setup I've ever done. No Unity, no Unreal project I've ever done was as quick to set up since the dependency chain is so small. For the Game Jam project, it was only Clang, the Vulkan SDK, and this build tool, which uses .NET. So it was the fastest getting up and running of any project I've worked on. So this was actually quite successful.
Interesting. So there was one question in chat. Are there any other reasons for just preferring Cargo other than what you brought up about data? And I think you partly answered that just because you want to look behind the curtain. But was there anything else on that front?
Yes. One of the reasons is that I have the progressive C compilation. So if you look at a lot of Cargo crates, and since I'm using a lot of abstractions that I have to write in C, if I don't want to have like huge bindings to huge C headers, which compile way, way faster in C. And so I want to have a solid C pipeline because I need to interact with the operating system. And so having a solid C++ compilation pipeline included with a solid Rust compilation pipeline just makes it a lot faster, the iteration times of working in the C code. Because a lot of other times I've used like the C compiler crate as a build dependency in Cargo, for example. And there you don't have as complex of a build system for, it's just a wrapper around the C compiler, so you don't nearly as far as complex a C compilation pipeline is.
Interesting.
And so I have to live with C even if I prefer Rust, right?
Yeah.
But I need it. I need certain things that I need to write in C. I'm planning to maybe write a conversion of SCV image, but for now I'm going to use the C version, put it in a DLL so that I don't have to link against the CRT. But I want those things that I need to have in C to have a very solid and very fast build pipeline as well.
Awesome. And is there anywhere we can go to learn more about the project? Like, is it open source or is it mostly just stuff that you're working on right now?
It is, but I wouldn't recommend it. I mean, if people are interested about it, I mean, it works just as well as a C compiler. If you are really sick and tired of things like CMake, that was my original motivation to write it, because Cargo is, for all intents and purposes, a good build tool, right? If you compare it with CMake or Premake, those are absolutely horrible. Right now on Twitter, very funny conversation between the maker of the SIG programming language and Jonathan Blow, trying to get LLVM up and running.
Yeah.
And it works neither with the, I don't know if someone maybe has already seen that, like, sounds like you have.
I watched the Spanish Jonathan Blow, but I don't understand very much of it at all.
Those suck. CMake, I've worked extensively with CMake previously at previous jobs, and it's horrible. And so this started out as a cross-platform because this also runs on Linux. Also runs on Mac, but I haven't tested it yet. I have a Mac lying around, but I would have to figure out Morton VK or Metal backend, but that's for another day. But the original plan of it was to replace CMake. And since it wasn't very hard to solve the problem of that CMake tries to solve, but in an extremely complicated way, I just use this for all of my C and C++ projects, and now I've extended it for us.
Awesome. Yeah, so a lot of people in chat are definitely agreeing that CMake is not an ideal solution for many people. So yeah, this is very cool to hear about. I think so. If you post it in chat, I'll relay it in the announcer channel, just for anybody who is interested.
I can get the GitLab link. I mean, it's open. The project itself I'm working on. It's not since me and a friend are planning to pitch that.
For sure.
Sometime. But all of the service layer I'm planning to have open source and the build tool as well. But it's not. There's no documentation. There's nothing. It is a project for myself. So it is just your random Joe GitLab project, not something that is very polished.
I think that's all good. I think people who are interested in maybe how this was approached would still gain some stuff from it. So yeah, that's very cool to see. Nonetheless, okay, I'll relay this over. Awesome. So yeah, thank you very much, Gibson, for going over that. Perfect. All right. So now we're going to hear from Alex about Dwarf World. I'm just going to give them the role here. All right, Alex, you should be able to speak. Oh yeah, sorry, and lots of claps for Gibson, of course. I forgot to say that. Let me see.
Hello. Does this work?
Yes, let me just see if I can pull up the stream.
All right, it seems to work. I don't know. Hi, I'm Alex. I work on a video game called Dwarf World, which is here. I have a website. You can check it out. This is me. This is my cat. I have a pretty awesome cat. Actually, I have more of them, but one of them is here, judging my Rust code, as all cats do. So I wanted to show you what I did here on my last update on the game. So it's an isometric game, kind of like Dwarf World and Dwarf Fortress. And it's inspired by all of these colony simulation games. Lately, I've been adding all sorts of things to it, like terrain generation. So here we can see slices through various levels of the terrain. My latest changes in the game include adding ores. So you can see here iron cells. I have also this inspection layer built with EGUI, which is pretty awesome. I love that library. It's just so easy to integrate. It just works. It has mostly almost everything you need from a immediate GUI mode library. Oh, I'm missing a window. This is absolutely not nice. Let me... Oh, it selects a window. All right, there you go. So this is my game, where you can see slices through the terrain. I thought it selected the screen, like it said on the bottom, but never mind that. So yeah, we can see slices here. I added a bunch of materials and logic to spawn. This is diamond, gold, all sorts of stuff like iron, copper, coal, and stone. And these are my dwarfs after they fought some other dwarfs. And I did a bunch of optimizations in which I actually want to talk about because it's pretty interesting. So I did a bunch of optimizations on rendering. And rendering the terrain went from 15 milliseconds to 5 milliseconds on release builds, which is pretty decent for how silly I rendered the terrain and so on. What's not nice is that on debug builds it went from 30 milliseconds to 200 milliseconds, which is kind of not cool at all. So that was kind of a pain, and it required more optimizations just to make debug builds workable. And just to quickly show off a bunch of stuff, I have here workshops where you can craft items like make baguettes on repeat, or you can, for example, dig in the world. So if we go to a level, of course I have cheat codes, but you can dig for metals like here. This used to be like a right-click menu, and part of my IMGUI integration adventures, discovered that I discovered that IMGI doesn't support right-click menus. So I'm kind of waiting for the author of the library to add a little bit more functionality there. In the meantime, I have everything here where you can put like a campfire, bed, whatever. You can put a table here. Actually, you can't because I don't have the artwork ready for it. And yeah, I guess if you have questions and or something like that, I can hang around the chat room afterwards. But this is my game. And oh yeah, I even have this window here where I can select entities and inspect people. So window specific, I just the assets are made by either me or my cousin. So they're kind of half programmer art, half more proper art. It's SDL and OpenGL2 as the renderer. So I don't have many. I don't use an engine, and I don't even use a proper ECS library. I used goggles, and I have my own systems built on top of it. And you can see here, for example, the dwarfs are made of various body parts, and you can look at the body parts. They have temperature. They have, these are the components. You can check out the renderer properties here. Yeah, anyway, it's super nice.
So we do have a few questions that have just popped up. So Quark asks, what's the tech stack other than eGUI? And then also Steel asks, what's it rendered with?
Yeah, so it's OpenGL2 for renderer. I can actually show you guys my Toml file, which is here. So it's raw OpenGL. Goggles is a smallified version of specs, basically, with a lot of stuff removed. And other than that is basically some logging and noises for the terrain generation. You cannot see. That's weird because I can see it.
We can see the cargo Toml, I think, as long as you're watching the... yeah.
It should be here. Because I see it on... yeah. On the stream. Well, yes. Yeah, it is exactly specs light. And the profiling rate, which is pretty awesome. And by the way, for anyone developing on Windows, Superluminal is an awesome profiler. I just love it. Yeah, but this is basically it in terms of, it's quite lightweight in terms of libraries and dependencies.
Yeah, and then where can people go to find out? So yeah, I know this isn't open source as of right now, but where can people go to find out more about Dwarf World?
So yeah, you can go to my website. I have a newsletter and I have a Discord room linked in there. And soon I'll start sharing pre-alpha builds with people, so you can try it out, break it, tell me about it, and then I can fix it, hopefully. So yeah.
Perfect. Yeah, so I'll just link that for in chat for anybody who wants. Awesome. Yeah, that was pretty cool, Alex. So I don't have too many questions because I very recently spoke to Alex with a lot of questions, and that is foreshadowing for something that hopefully everybody will get to enjoy in a few weeks' time. But yeah, until then, Alex, it would be cool to see next month maybe some more progress on what's changed and everything like that. So thank you very much.
Absolutely. I also, thanks. And I also stream on Twitch. If you guys want to hang out, I'll be on there tomorrow at 7:30 GMT. Thanks.
Yes, definitely go check that out. The Twitch is on the Dwarf World website, so feel free to go check that out. All right. So next up we have, let me see, M. Sigrilreith, I believe, to talk about their GLTF viewer using RustGPU. Oh, very interesting, very interesting. Let me just get the permissions all figured out. All right, you should be able to speak. sec. Let me just. I think I gave you permissions. Alright, we're just getting the audio figured out on this one. All right, and then also this will be the last presentation, unless anybody else wants to message me. If you have something that you're like, oh, it would be cool to show off for 2 minutes, definitely feel free to message me. We can put you in.
Hi, does it work?
Yes, perfect.
Awesome. Hello, everyone. So let me share screen here. So can everyone see it?
Yes, I think just increase the font size a little bit.
Okay.
Just Control Plus probably. Yeah, perfect.
So I've written a small GLTF viewer using RustGPU for my shaders and OpenGL for the host API. Just an image here. Show what it looks like. So nothing too special here. We have a small skybox showing the diffuse background image here, and model, which is basically just lit by image-based lighting. And yeah, that's basically it. Runs pretty smooth. And go quickly over the setup here if you haven't used RustGPU yet. So I've basically here have my main crate, which does the OpenGL rendering, etc. And if you want to use RustGPU, you basically have to include your SPIR-V builder in a builder.s file. And there you can specify a crate which will contain your shader code. And regarding memory model, for me, it's OpenGL and the SPIR-V version you want to use. And then you have your shader crate here, which will link your SPIR-V STD probably for stuff like storage classes, texture support, etc. And I have a small shader library, which I've written myself in Rust, which basically does something like math support and, for example, here full screen triangle to generate positions. And the same crate here I also use on my host crate, which you can see here. And I use it mostly for something like matrices creation from a perspective matrix, lookup matrix, etc. And so let's quickly go over the shader here. I have my skybox shader, which is vertex and fragment shader. Everything sits in one file here. And on top, there is my PBR implementation for the image-based lighting. Quite heavy fragment shader, which has quite a few inputs here from my vertex shader and lots of textures to look from. And yeah, that's basically just my tangents, normals, etc. creation, diffuse lighting, specular lighting, ambient occlusion, and then just combine everything together and store it into the output. And I want to go quickly over the skybox, for example, here for better understanding. So you basically specify one shader as a function using special entry point. You specify it here, for example, vertex or fragment. And then as function parameters, you have your input and output for the vertex shader. This is, for example, the vertex ID, but you can also add something for your vertex buffer inputs for the different attributes, like normals, positions, etc. And then your vertex buffer outputs with this output storage class, which is defined in the SPIR-V STD. And here's well another one. This is some decorations for the SPIR-V stuff. And here I have a small uniform and So you basically have to block assign it, representation, etc. Needs to be copy and clone to work here. The interface is not set in stone. It probably will change over time to make it more simple, stuff like that. For now, you basically always have to load these storage classes, and then you can use them. Here, for example, I use the generate a full screen triangle and then do the inverse of my view and clip matrix to basically get the skybox vertex where I will have to sample into the cube map later on here. A bit messy a bit because SPV STD has an own math library and I use my own here. So I have to convert from stuff. But yeah, that's basically it. On the host side, there's nothing special actually going on. Where's my shader? Yeah, there's this BRV shader here. There will be some environment variable set by the SPV builder. And then I just included the output SPV file and just generate shaders from it for OpenGL and then generate my graphics pipelines. So for the generated SPV file can be quite big. I have to say you probably will have to add some features if you want to the RustGPU library. The generated code is not optimal, but I guess it will improve, and it's also not that heavy. There are, of course, some features missing, but it's pretty usable for now. And something fancy you can use actually is they support the ASM feature, which allows you to basically write SPV code in Rust, and it will basically just generate this code here in line, which is pretty nice to do most of the stuff you want as extensions. That's basically it. Thanks.
All right, that's pretty cool. I was pretty excited to hear about like RustGPU when it came out, but that being said, I haven't done too much with shaders and stuff myself. So that was definitely pretty cool to kind of just see an example of it being worked on and stuff like that, or kind of like what the experience was like. Do you have, if you have any open source stuff, if you just drop it in the channel, I will make sure that people can go check it out. Is a project open source?
I pushed it yesterday or so.
Okay. Yeah, so if you just put it in the Meetup chat, then I will relay it. And everybody's clapping. Very good, very good. RustGPU, very cool. I do like.
There was a short question from Limith regarding blockers from RustGPU. So far, you basically compute shader. There are storage buffers which don't really work pretty well so far because it's just not implemented. Something else are for loops are not supported because enums and option is not possible so far. But you can use while loops, even though they will generate quite a lot of CRV code. And this is something I noticed, some 10% performance decrease here because it's not optimal, but it generates correct code, which is great already. But that's probably something to keep in mind if you want to use it.
All right, awesome. Thank you very much. So next we will move on to, let me see here. We have Emery talking about the progress for the Amethyst port to Legion ECS. Oh, I'm actually, this is very cool. This is I'm quite interested in this myself. So Emery, I will give you the permission to speak. You should be good now. Where did he go? You might have to rejoin the chat for it to redo the role properly. I'm not entirely sure.
Hello, can you hear me?
Yes, perfect.
Great.
So
First off, I wanted to say...
screen share, perfect. I'm just going to run to the bathroom quick. I'll leave you at the helm for a minute or two, and then I shall return.
Great. Okay. First, I just wanted to say that these projects that I've seen so far in the meetup have been really awesome. I'm super excited about all these developments in the Rust community. I've been working the past 2 months on 2 different Rust projects. One is a game using the Amethyst engine, and here on my screen you can see for the past month and a bit, I've been leading the charge to finish the port to Legion ECS system for the Amethyst project, the Amethyst game engine. Full-featured game engine with crates for everything from loading GLTFs to doing audio, 3D audio, and lots of other things. You may be familiar with Amethyst. It's one of the more popular game engines in Rust, and it's been around a while. There was sort of a stall in the project, as some of you may know, but we've kind of kicked it into gear, and now, as of this week, we've actually been able to merge the Legion port to master, and it is in a working state. A majority of the examples in the project have been converted to Legion, and as you see here, as I had up earlier, there's a few remaining ports that are needed. Basically, the prefab loading system and the GLTF loading systems haven't been ported all the way, but the majority of everything else is working really, really well. We are looking for any contributors, and now that the master branch is unfrozen, bug fixes and anything else, to get out in the big Legion 0.16 release. So I don't really have any demos prepared, but these there are a bunch of working examples in the repository that I encourage everyone to check out. And the Amethyst Discord is a great place to chat, or if you're interested in contributing, you can send me a message directly. Yeah, I think that's it as far as what I have to say, but please join Amethyst.
Yeah, awesome. I was quite interested about this because with when it came to ECSs and Amethyst and stuff like that, I kind of read into it a little bit. Again, I'm not super low level when it comes to Rust development, but I think I've sort of read a couple of different articles about Legion versus Specs versus a few others, and then kind of looked at with Valoran how we still use Specs and stuff like that. But it's definitely it was pretty big to see the Legion switch for Amethyst.
If anyone wants to chat about the differences between Specs and Legion, I'm available. There were some in progress ports, and I ported some of these crates myself between the two. I really like some of the ergonomics in Legion, and the performance is great, and some of the cool things you can do with it versus Specs.
Yeah, for sure. If you toss a link, everybody can find Amethyst pretty easy, but if you toss a link to the Amethyst Discord, I can put that in the meetup announcer for anybody who wants to check that out as well.
Great.
Awesome. Thank you very much, Emery. All right. So next up, let me see. We have Fritz, who's going to talk about their project, which is a Vulkan Renderer. Let me see where. Let me just get the roles for you. There you go. You should be good. Yes, claps, of course. Lots of claps in chat. Very cool.
So, hello. I'm gonna screen share over a camera. This doesn't work. Okay, never mind them.
Over a camera, unfortunately, since we have more than 25, it's a bit difficult.
No, it doesn't work. It's just a workaround I've been using to share a single screen.
Yeah, I understand that.
So, I'm just gonna share my VS Code quickly. This is my cargo tunnel. Well, actually, wait, let me just start it. I'm a bit nervous right now, but I think
no worries. All good.
Yeah. Okay. So I'm gonna share this window like this. So can you see this? Yes. So this is just a little sample project I've been working on, a little learning project. So yeah, I wanted to learn Vulkan for a long time now, and I've been like going at it a bit. And this is just like a sample OBJ that I've loaded with simple shading, like you can see here with the reflection and all that stuff. And yeah, so this is actually using a Vulkan bindings crate that I wrote myself as like an well, because I've been interested in doing so because mostly as a learning exercise. This is mostly all as a learning exercise, but also to improve the ecosystem of the crates in general and help the community. And yeah, this is a project to like get to learn Vulkan and how it works, and especially synchronization and all that stuff, which you need to spend quite a lot of time on to fully grasp. I guess I can show basic stuff about Erupt if you guys want to check that out as well. Which is the Vulkan bindings I use for this. Can share my browser, I guess. This is Erupt. It's yeah, it's small Vulkan bindings. If you are interested in checking that out, of course you can use other Vulkan bindings as well. They are perfectly fine to use. They get quite a lot of development, but you know, this is the thing I've been working on. I guess here's the GitLab for it. I can send a link. I can also send the GitLab for the game I've been writing using this. It's not really a game. It's more like you know a learning exercise. Yeah. I can send you the link. Can also send it in here. Yeah, of course. Yeah, I guess I can share my code, where we use code again. Yeah, well, of course, I really use Vulkan directly. This is my pipeline code, for example. Yeah, just setting up the pipeline and they're directly doing like low-level Vulkan draw codes, like actually how they work. The only thing I'm extracting really is the memory allocation, for which I use another library, because that's something that you will need to like put up. Yeah, it's not that easy to write it yourself, and I prefer setting that work off to another person that is more knowledgeable and how to properly set that stuff up. Yeah, and that's the only thing I'm really extracting, but luckily there's a good library for this called GPU alloc. I guess I can show my cargo terminal again. It's not that big. It's just a simple renderer with Rust. I used Shipyard ECS, but didn't actually create any entities yet. Just funnily enough, yeah, it's just use it as a component store. Yeah, I can in specs you would call it a resource. If anyone is familiar with that. I guess that doesn't matter. Basically, yeah, I use Clam for my math library and the GPU alloc for the allocation. Yeah, it's not I didn't write this myself. It's just a fork.
And then someone asked in chat, is Erupt, what's like the feature completeness of Erupt versus something like Ash?
Yeah, it's more. I think you could you could say Erupt can do everything Ash can. It's just that the whole premise of Erupt is that I automatically generate as much as I can based on like the Vulkan XML and all the stuff. Ash is actually getting a rewrite that can do it as well as we speak. But yeah, this is just a hobby project, and well, mostly the extensions. If you know Vulkan extensions, then Ash only provides like low level, more lower level access to the Vulkan extensions, while I automatically generate high level bindings, more like high level Rust helpers around these Vulkan extensions, which Ash can currently do, but is in progress from them. So and it's perfectly fine to use Ash as well. So again, I think.
Perfect. Yeah, that's pretty cool. Yeah, so I posted your links in the announcer chat, so anybody can go check those out. Yeah, it's pretty interesting seeing like the ways to use like Vulkan and like lower level stuff. But I think it's something that I have not dipped into too much, and so good for you for that, definitely.
Of course. Well, I don't think it's actually a good idea to use it if you just want to render something. Then use GPU or something like that. It's a really good project. But I use Vulkan myself because I want to learn how that stuff works.
That's a very good way to do it, for sure.
Yeah.
Awesome. Well, thank you very much, Fritz.
Yeah, no problem. I hope it was fine to listen to. I'm a bit nervous, but yeah.
No, it was good. It was good.
Okay, thank you.
Cheers. All right, next up we have open square bracket, close square bracket, dash, 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 open square bracket, close square bracket. That's exactly how it's pronounced.
Thank you for saying my full name.
Hey, no worries.
All right.
You should have permissions to screen share, I think.
Hey. So I've been working on this for about 1 month. It is a 2D fighting game in Rust using GGeasy and my own engine. Whatchamacallit? Right now it has it's pretty basic, but it has one feature which I'm very proud of, which is that I have basic netcode working right now with rollbacks, which requires the state system to be what's the word? To do rollback netcode, you have to be able to roll back to previous states and then update several times in sequence. So by writing my own stuff and not using an ECS library or anything like that, I'm able to do that. I'm able to do that without having to serialize states, which is something that's tricky to do with existing ECS libraries. That said, serialization and deserialization in Rust has been a big help to me. If you look at the individual moves here in slow motion, you'll see that each single move has a lot of individual hitboxes, particularly this one. This right now, I have that done with in a JSON file that just has all of them stored in a human readable format, which was very easy to set up using SurJSON. And so I can make changes to that and live reload it with the press of a key, and very quickly prototype these moves. it was also very easy to implement the networking part. And I think
that's pretty interesting. Everybody's saying art is very cool, so good job on that. Yeah, it's definitely looking pretty good with all the animations and stuff like that. Someone also commented easy networking. So what's your networking strategy? Because I think a lot of people will either like think networking, they've found a good solution for networking, or just have no idea how netcode would ever work.
Right. So I based it on Laminar, and the networking code is still a little bit messy. But you have the basic packet, which has an acknowledgement and a which has an acknowledgement which says the last frame that we got, the current frame, and a vector of the inputs that have not yet been acknowledged. So if the last acknowledged frame was if the last acknowledged frame was frame 500, we're on frame 505, we send 5 inputs. This way, if any packets are dropped, it doesn't matter. Rollback netcode is a form of lockstep netcode in a way. So there's no authoritative server client, since both players advance the game state at roughly the same time. You do not ever need to send full state updates. The clients remain completely in sync, using only the information of what buttons the other player is pressing. It happens that a button that 1 frame's worth of inputs is 8 bits. So
awesome. Yeah, I think in networking, when you're coming up with your own protocols for stuff, because like there's different layers, right? Like you have to determine how you're going to send, or how you're going to represent your data that's going to be sent over the network, but then also the layer that you have to actually care about how packets are being sent back and forth. And then is this over TCP or UDP?
UDP.
Okay, interesting.
And what this is, and you might think that's kind of funny because the inputs do have to arrive.
That's what I am thinking. Yeah.
But the nature of writing a game like this is that I'm not using UDP because packets are really unreliable. I'm using UDP because I am much better at handling dropped packets than TCP is.
I see. Yes, that is a big one.
And in this case, the strategy for handling lost packets is redundancy.
Yeah.
Since information is only 8 bits, I am just sending. If there's 4 frames of latency between clients, I will be sending a single frame's worth of input 4 times, essentially. It'll get sent in every packet until the receiving client acknowledges it. Okay. This is a perfectly fine strategy for handling dropped packets.
So yeah, that's the thing about TCP is it will give you like a lot of guarantees, but it also gives you a lot of nice overhead. And so if you can do it in a different way that works for you, like yeah, exactly, just do it. Just do UDP and make your own TCP on top of it. Yeah, not bad. And then some people in chat asked for some good resources in networking programming. So if you have anything in particular that you think is good, feel free to drop in chat. And also, this project, I think you said it was closed source.
I just haven't put it anywhere.
All right.
I've only been working on it for a month. I don't have any links for you.
All good, no worries.
This network code was heavily inspired by GGPO. Which is a C networking library used for rollback and fighting games. So looking at that is
yeah.
So looking at that as a good resource.
Yeah, I think Zester also just mentioned Gaffron Games, and that networking write-up is very, very good in my opinion. There's a lot you can learn from it. And so, yeah, just take a look at some of the other stuff. If you want to post some of the things that you just discussed in chat, then I will relay them as like valuable piece of information. But yeah, thank you for showing that off. Awesome. So,
check it out.
All good, all good. I think we have one more that we are... Oh, yeah, so claps in chat, of course. There was discussion if we should make a separate chat for claps in particular, just because they're very overwhelming. But then there's the counter argument that it's a good way to see where the split up between different presenters is. And so, yeah, I think either way is good for now. It'll work. And sorry, yeah, for anybody on Twitch, I'm saying chat a lot, but I'm referring to the Discord chat because that's where like most of the action is happening for sure. All right, so right now we have, let me see, Das Etwas, I'm guessing, is going to talk about, I'll just give you permission here, a prototype of theirs with some screenshots and a voiceover, I believe. So I should have given you voice permissions. You might have to rejoin the channel to be able to speak. And then if you just want to send them to me, then I can show them. Hello, hello?
Okay.
Perfect.
So I'm going to share my screen.
Perfect.
So I'm going to show my game. As of now, I'm still unhappy with the name, but I named it Alluvium. I'm open for new ideas. And I got a project compiling that's part of the project I want to show. But the main game is here. So basically, Alluvium is supposed to be a mix of a few popular games. Maybe you guys know, you folks know Kerbal Space Program, or Scrap Mechanic, or Space Engineers. Basically, these games are sandbox games which allow you to build vehicles and to travel around the planet. Kerbal Space Program features orbital mechanics, like in a very intuitive way that teaches people how rockets are maneuvered, and it's applicable to real life, which I find really cool. And Space Engineers allows you to build like structures out of large voxels that have great detail and machines. And basically, it has an item system, inventories, energy storage, and that stuff. And Scrap Mechanic is one of the games that relies heavily on physics constraints to build like actual car suspensions, for example, with springs and bearings. And I wanted to combine all those aspects, and it's basically a passion project for me, which I do in my free time because I'm a student. And I worked on this, I think, for like 5 years, and as you do as a programmer, you completely overestimate your capabilities for for time and how long things take. Because when I started with the project, like I think 5 years ago already, completely overwhelmed myself with goals. I started with the Java prototype in OpenGL and basically learned graphics programming that way, and also proper programming in Java. And then I noticed that Java and object-oriented languages I don't like, and then I discovered Rust, and it was basically a perfect fit for me. So I rewrote the whole engine. It's all made myself. I use specs for the ECS in Rust. And then with time I understood that specs can be really nice compared to like object-oriented programming. And yeah, basically the game uses what you're seeing here is a planet rendered using Ralith's library planet map. And I use a WGPU rendering backend. Right now it's running on Vulkan because other backends sadly don't work, but I plan on helping in some issues on WGPU. So Vulkan, the Planet Map library by Reddit has an example shader and example application which runs on raw Vulkan. And I basically ported those shaders over to a WGPU compatible format. That took quite a bit of time. And it uses textures which are generated on demand to store height map information. And this is all really cool and technical stuff and taught me a lot about GPUs in general. And as of now, I'm walking around on the terrain, as you can see. But Planet Map is a planet rendering library for all scales and level of detail. So I can just fly out. There you see the whole planet. I have some debug errors going on here, and they're in my face. So, and the bitrate is pretty bad, I assume, because of the grids. But I couldn't just modify it so quickly to not render those. It would have compiled too long. Yeah, basically I can zoom a bit. You can see the planet, and the LOD is worse, as if I would standing on the planet. Yeah. So I will fly back and show some gameplay features, because gameplay should play in like a person's scale, not interplanetary scale, because you should be able to build vehicles with voxels. And now there's the other very technical part. So I can walk now and spawn a voxel grid. And as of now, this is completely programmer art. I used some copyrighted textures before. I needed to quickly edit those out and make some normal maps. This car, physics glitches. It's a rigid body based character controller too, which is why it wobbles. So this car has a diffuse texture. So I use normal mapping, diffuse texture, and a material texture. This material of voxels I call plating, just some metal stuff. I couldn't come up with a metal texture that quickly, so I just used a normal map of another material. That would be the wood material, and I can build that. And this is a building system where you can drag a rectangle which has a maximum size, which is heavily inspired from scrap mechanic. So this is the wood material now. Basically noise, and it's mirrored the text. Yeah, and I can walk around on it. In the future, I would like to have different friction coefficients and stuff like that, because I'm using N-physics. I plan on switching to Rapier as well, or however that is pronounced, for better performance, of course, and yeah.
Awesome.
So. And I have different materials too. I use for deferred rendering for my current system, and of course transparency isn't fitting well in this system. And voxel grids can also be they can contain voxels and also parts, and these are discrete objects with own collider definitions. I just finished working on the placement system. Basically, you can rotate the part before placing, and it may not collide with anything else, and must have a valid attachment point to be placed. So I can now place the chair here. I call it seat. And as you can see with the arrow, just the debug hell for me, it shows the inverse of the normal vector. You can see it has a box collider. And then I can also attach voxels to it. And not on this side, because it's not a valid side to be placed on. I can place a voxel here, then I can cut a seed out, for example, and then it falls down and is split. And this was a lot of work and testing, and a lot of vector math. For example, calculating the inertia tensor of these rigid bodies, and it's very physics-heavy stuff. But I'm happy to kind of have it in a working state now. Yeah. Do you want to say something?
Yeah, I was just gonna say, when you zoomed out from the planet, that was definitely pretty cool because like it allows you to kind of see like a much grander perspective of like what this project accomplishes. And then Zester mentioned in chat, I love that when standing still, the global velocity is still non-zero as the planet spins, presumably.
Exactly, the planet is spinning.
Yeah.
I'm gonna fly up a bit.
And yeah, Zester mentioned that's like a very hard thing to accomplish.
That is indeed very hard. Like I have so many newly developed technologies that I just also was fond of doing completely myself. Maybe a bit stupid in the end, because of course smarter people than me already dealt with this, but I wanted to learn. So basically the planet is rotating, it's not moving, it's not in an orbit, but there's the sun. And I used the planet scales from the game Kerbal Space Program, which means this planet has the 10th of the radius of the real Earth, which is very big, and using normal floating point math wouldn't suffice here.
Interesting.
I need to use double precision and calculate everything in double floating point precision spaces, and then convert to float in the last minute before rendering. And as you can see, these spheres around me, basically these are two transparent spheres, and the outer one basically says how big the physics world is, because I tried already in my Java prototype using bullet physics, different language, different native libraries too, and basically when the planet is moving, those physics engines they just can't handle a moving surface like this. It jitters around, of course. If we want centimeter precise movement in a game like this, you can't have everything moving around. You need to have something standing still. And as an optimization, physics engines also tend to freeze bodies that stand still, which greatly improves performance, because they just omit the near phase collision checks and such. And I really want to depend on that to optimize it, because of course you can't have a planet full of stuff moving on the ground. It would lag very much. So yeah, these cars are basically frozen, presumably. And so that I can realize that when I'm standing here, I really stand still in the physics world. The whole physics world needs to be moving. This is very complicated. Maybe you know from college physics, moving frames of reference, and this isn't even an inertial frame of reference. It also spins with the planet, which imparts fictitious forces which have to be calculated by me. Yeah, this is pretty complicated. So if I would make the planet spin faster, even if I don't. If I'm not moving in local space, I would be flung around because of the centripetal, or the opposite of that, force by the spinning. And yeah, this took basically a lot of time testing, because I'm not that good with debug visualizations, as you can see with the transparent errors. And just swapping a few minuses and multipliers and divides here and there. And it's basically a precious little project of mine to have this all sorted out. And maybe now that I have building done, I can implement some gameplay features too. Like actually sitting in a seat, maybe.
Awesome. Yeah, this is definitely a very cool product. I think there's a lot of interest in chat relative to like the physics and stuff like that.
Yeah, I think I could go on 40 minutes talking about the details of like how I render those voxels. If I can show you enable wireframe. Basically it's greedy meshing, no geometry shaders, fancy stuff like this. To write this algorithm was a pain.
Yeah,
this is an understatement. And I built basically, this was my main motivation as a fun fact to switch to Rust. Basically, this greedy meshing algorithm I wrote in Java already, although a bit buggy. And then I figured I could learn Rust by rewriting it in Rust. And this actually got me started into the language, and seeing the algorithm take for a large voxel model of an A380 like instead of 10 milliseconds, then I was completely sold in Rust. And yeah, this just the project, just code quality also just improved over the time. And I also built a test viewer for seeing step by step how this voxel meshing works with KISS 3D, which is made by Sebastian Crozet, which is also the lead dev on Physics and Rapier. Very nice dude. And yeah, that was compiling in the background. I don't know if I can show that now. I should be able to run it, not in released. Yeah. So I need to know some hotkeys right now. I'm sure I can find those out quickly. E, Q, and R. Okay. So. Okay. Okay. You can see this is the KISS 3D renderer, and I use a voxel model of a A380 to basically stress test it, and also to benchmark it. I think to generate the meshes for this model it takes like at most 17 milliseconds or so, and it's a pretty fun project because I can deal with high-level data structures and also optimize it down to the bits and see exactly what effects some short circuiting, for example, has in loops, or laying out like arrays of structures or structures of arrays. And yeah, this is a sparse data structure with one level. It's not an octree. It's with chunks. In this case, it's 8 by 8 by 8 chunks, I think. So this is just a debug view displaying chunks with random colors. And if I press R, it should switch something. Okay, this is synchronous code. It takes a bit to work. Yeah, the test renderer here, KISS 3D, of course, doesn't cope well with hundreds of individual faces. More like 10,000s.
Yeah.
Yeah, I'm not fluent in the controls of this tool anymore, but as you can see, I do graphical meshing. Ah yes, okay, this is the physics perspective, and then I do cuboid merging, like merging the voxel cubes into larger cuboids, and those are then put into the physics engine. If I press E again, you can see the voxels are merged into the X direction right now. If I press E again, it should lag, and then it's merged into the X and Y direction. You can see vertical strips and horizontal strips. And if I press E again, it's the final representation, which would be then used in the game.
I see. This is very cool. Yeah, I think it would be cool to kind of see the progress as it goes along when it comes to like more gameplay and like the physics. I think everybody's very interested with the like the tech behind this project. So definitely well done on this.
I'm very fond of sharing my tech. Like I'm not planning on open sourcing my game yet because I'm too shy basically. And I don't want it to be judged that well, but I know it's not a good argument. Very many people will be saying the opposite. But and also, yeah, I plan on maybe including some proprietary software and maybe publishing the game, also making a bit of money. But I definitely plan on keeping some PR, and I already have a Discord server for it around. But I just feel like it doesn't have enough gameplay features for it to be like a good game yet. This could be, yeah, maybe the topic of a write-up, of course, but I need to add some gameplay features, because you have to imagine, of course I'm excited about all the tech, but if you play it basically pretty lame right now.
Well, but I mean, a tech demo is still cool for the people who know about how like the physics work for it and stuff like that. And it appears that
absolutely.
a lot of physics people in the chat definitely were looking at it and being like, "Oh, there's some nifty stuff here." So, yeah, but
also,
where you go?
Go ahead. I also have a bit of an inspirational speech because I played those games, especially Scrap Mechanic, which makes it's a lot of fun to play. I have about 1,000 hours of playtime, I think.
Mm-hmm.
And I built very many physics contraptions and always found a bit of glitches maybe or gameplay features that I would have wanted in a game that are hard or impossible to mod in, because they do have a modding system. And that's the main motivation of my game, to basically beat the game but better.
Yeah, awesome.
And another maybe physics trick, as I said, worlds can move and are not inertial reference frame. They can have fictitious forces applied. So when I get far enough away from this planet, I have my own world, which with these basis vectors, as you can see, with the lighting maybe a bit harsh. Yeah, the basis vectors. And the red arrow points towards the sun, so that's not as visible. So as you can see, when I apply control input, maybe to the right, and I let go, then the world catches up with me. And that's basically designed so when you have a spaceship and go on a trip or in orbit and you don't have acceleration, you're just coasting around in orbit. Of course, you should stay near to the origin of the world. Maybe with double precision floating point numbers, that the precision isn't as good of an argument, but definitely things should stay still. It's much more stable in gameplay, I guess. As you can see, it's hard to visualize, but basically, even if I don't accelerate, so I'm moving to the left now, and I let go, then I move in the global direction just as I was before, but the world is moving around me and I get accelerated in the opposite direction. It just, then it makes sense. I behave like everybody behaves in global space, basically.
I see.
It behaves like there was one huge physics world around. And yeah, as I said, to make that work was a bit of work.
Yeah, definitely.
And when I spawn those cars, it was also a great ambition of mine to not have the physics like, for example, Scrap Mechanic, where speed matters, and some things are derived from the physics, body speed, I don't know. Basically, if you have a car moving, it's moving, and if it's at rest, it's at rest, but to be correct physically, you have to, of course, also ask what the frame of reference is. And in this case, the car and I are floating around here, and if I place another car, you can see the world will adjust itself to also always be in the center of mass of things. And I plan to really put an emphasis on making it physically correct, and this is the next point why the character controller may be so wobbly. Of course I can't stand on here because it's a microgravity environment, but I really want to have something, a game for physics enthusiasts, maybe to create space stations which can generate artificial gravity by turning a huge station. Already tried that out using some basically voxel STF functions for generating such a ring.
And does it simulate pretty well?
And standing in it. It basically works, but I still have to put a lot of work into character controller so it isn't as wobbly. But
Yeah.
basically you should, of course, stand always in direction of acceleration, not wherever down is.
I see.
Because in a bus, if it accelerates, you also tilt forward. And that should also apply in my game, but not as wobbly as it is right now. So if I go into standing mode, of course it jitters around a bit. Because those are the acceleration vectors and they get feedback from turning itself, etc.
Awesome. Well, yeah, thank you very much for showing this off. This is definitely a pretty cool project. I hope to see a little bit more about it. Yeah, so I think I'm gonna cut off the demos here, just because we're almost at 2 hours on the meetup so far. Oh, yep, claps in chat, of course.
Can I say one more thing?
Yes, go for it.
I would like to thank the WGPU team, because they are very helpful in helping me debug, and also Ralith personally, because he helps me very much. And also the Rust community is very helpful and non-toxic, as I experienced in quite some others, in basically explaining me the fundamentals. Yes, thank you.
Yeah, it's good to hear. I think that's definitely what a lot of us are here for, is the community behind Rust. And yeah, especially with a lot of different projects in the graphics side of Rust and the physics side of Rust, there's definitely a lot going on. All right. So I'll go back to streaming the presentation here. I think, wait, show and tell, we just did show and tell. Announcements. So now we're at the announcements part of the meetup. If anybody has anything coming up that they want to announce, just feel free to send me a DM. And if it fits in the announcement section, I'll put it up here for anybody. So I think the only item that I have so far, and one reason that I was originally intending on having the meetups on the second Saturday of the month is so that we could have the Rust Gamedev newsletter come out already, but it is still in progress right now, and so it will probably be out by next week or something like that. But yeah, so that should be out pretty soon, I think. Oh yeah, the other thing, I do want to show off like the Rust Gamedev podcast, like the kind of stuff that has happened in the previous month, since there should be at least one episode per month from now on. So there was an interview with Fedor, who was talking about their work on the macro quad and mini quad games libraries. And so if you want to check that out, I will drop a link. Rust Gamedev podcast. So if you want to go take a look at that. And then on the topic of the Rust Gamedev podcast, if anybody has some interesting things that they think would be cool to have on the Rust Gamedev podcast, feel free to send me a direct message, and we can talk about getting you on an episode if it lines up with our schedule and everything. So other than that, I think that's pretty much it for the formal part of the meetup. These aren't actually real slides, there's just more template stuff down there, so we won't worry about that. So thank you everybody for coming out to the Rust Gamedev meetup. Since this is the first iteration, please message me if you think that anything could be done better, or if anything should change, or if there should be like a different way of going about the show and tell, different way about doing stuff on Twitch, different way about streaming. Feel free to message me. I take all criticisms right now because I think they're all very valuable and definitely helpful on getting stuff sorted out and running nicely. And so for now, I'm going to move over to some of the smaller meetup hangout chats. If you want to hang out for a little bit, feel free to hop in there. Everybody should have voice privileges to speak. And we'll see everybody next month on whatever that Saturday may be. Thank you everybody for coming out.